Hello everyone, my name is Saurabh Singh. Today I am going to teach about the advanced geotechnical engineering. This is unit number 1 and that is my lecture number 1. And this is the basics of foundation. Here you will know what is the basics mean of the foundation in geotechnical engineering. This will be your first lecture and here you will understand what is the basic function and basic requirement of a foundation which we build for the structure. First we will see what is our learning objective, because learning objective, this is a very important thing what you are going to watch in this video, and you will get idea what is the learning objective of this video. First one is to know about the foundation of structure, and second one is to understand different application of deep and shallow foundation. As you know, foundation is the very most important part of any kind of structure. If you are building a house, if you are building any kind of bridge, if you are building any kind of other structure, then foundation should be strong. And if you are a civil engineer, you should have a good knowledge of foundation, because everyone says foundation is the base of any structure or anything. This is very important. And what is the learning outcome? As you can see here, you will able to learn about the uses of different types of foundation. Like you will when you will watch this full video, you will understand what kind of different foundation we are using for the different structure, and you will also know what are the difference between shallow foundation and deep foundation. It means you will know where we need to build shallow foundation and where we need to build deep foundation, and what are the difference between both. And this is very important to know. Come on. Yes. First, we will see shallow foundation. As here categorize shallow foundation and deep foundation. Foundation is divided into two parts. First one is shallow foundation, as you can see here, and second one is deep foundation. If you will see the shallow foundation, it is also categorized into two parts. First one is straight foundation and second one is made foundation. If you will see deep foundation, there is driven piles, drill shaft, and other cast piles. And shallow foundation, and this is also a comparison between shallow foundation and deep foundation. As the name, shallow means, if you can say in Hindi, it means chichla, and deep means it means there is some deepness in this foundation. That's why, according to name, you can differentiate what is the shallow foundation and what is the deep foundation. First, we will know shallow foundation. After that we will know about straight foundation and mad foundation, and after that we will know about the deep foundation and about the types of, and you can also call the subcategories of the deep foundation. Now there is the definition. Types of foundation: shallow foundation, founded near to the finished ground surface, where the founding depth, which is also denoted by the df, is less than the width of footing. It includes footing, mat, and raft foundation. And what is the pile foundation? You can see here. Long and slender structure member which transfer the load to the deeper soil or rock of the high bearing capacity, avoiding the types of foundation. Pile foundation: long and slender structure member which transfer the load to the deeper soil or rock of the high bearing capacity, avoiding shallow soil of low bearing capacity. Means you can also say it where we first you need to know where we provide the shallow foundation and where we provide the pile foundation. Shallow foundation means where we don't require too much bearing capacity. Like if you are building very high rise building, there you need to require to build a deep foundation, because the load of the structure will be more. In such case, you cannot make the shallow foundation. Shallow foundation only you can prepare for the lightweight structure. Suppose you are going to build a 2 or 3 floor building or structure, there you can easily make the shallow foundation. If you will see the bearing capacity of shallow and pile foundation, the bearing capacity of shallow foundation is much better than no bearing capacity of pile foundation is much better than shallow foundation.
Now, where we what is the shallow foundation and where we use the shallow foundation and what's the reason behind it. We will know about these things in this frame. Usually, the more economical option. Like if you are going to build shallow foundation, it will be more economical. Like you cannot uh, you cannot make a deep foundation for a lightweight structure because you can make it. But what will happen? The cost of your structure will be increased, and in this case your structure will be not economical. That's why we only prepare shallow foundation for a lightweight structure. As second point is there, as a general rule, consider deep foundation only when shallow foundation do not give the satisfactory design. Like as you can see here, suppose you are going to you are going to make a foundation for a pipe, or you can also call it a uh, river bridge. Then on that case you cannot prepare shallow foundation, because for shallow foundation you need a large amount of area, and in the deep foundation only you need low area where you can build the deep foundation. Means suppose you are going when we prepare the foundation for a river bridge or piers of a river bridge, we have to make a coffer dam. What is the meaning of coffer dam? Coffer dam will restrain the water in that area. And if you are making the shallow foundation, what will happen? The size of area will be increased, and you cannot make the and this kind of structure is not possible in the river because you have to hold the water. In water, you cannot do the construction. What you have to do, you need to stop the water. That's why there is some uh, certain regulations and certain, you can also say there is also some restrictions of area and restrictions of size. That's why we need to build a deep foundation. Now we will see the types of shallow foundation. There is four types of, as you can see here, sprayed footing. And one more thing I would like to clear here: foundation and footing both are the same thing. Sometimes we call it foundation. It is like footing, and sometimes we also call foundation. It is also okay. Both word is suitable for the shallow and deep. And generally we don't call deep footing. We generally don't call it. We only use the footing word for the shallow foundation. Now we will see the types of shallow foundation. First one is straight footing. Straight footing is also categorized into four parts. As you can see here, square, circular, and rectangular. And by the name you can understand what will be the shape of these foundation, because square means it will be square form, circular it will be in circular form, rectangular it will be rectangular form. Everyone, if you are a civil engineer, you must know about these difference between square and rectangular. And second point is combined footing. Combined footing, there is also name combined. Combined means two footing will be joined together. It's mean combined footing. And continuous footing, as you can see here, it means the footing will be joined continuously. That is the meaning of continuous footing. And last one is mat and rough foundation. As you can see here, everyone knows about the mat. All person are using mat in their homes, and it will be like a mat. Means the area of mat foundation will be very big. That's why we call it mat foundation. Okay. One thing I would like to also clear here: if you are going to build a deep foundation, you need less area. If you are going to make a shallow foundation, you need large amount of area, because shallow foundation is, you cannot build in a small area. That's why uh, a less area required for the deep foundation and big area required for the shallow foundation. Yes. Now you will understand what is the shallow foundation and what is the deep foundation and what are the types of the shallow foundation. First foundation you can see here, it is in square shape. This is called square foundation or square footing. Generally we call it footing. You can also call it footing. And one thing you will observe here, the base. You can, if you will see here base, the B will be always greater to T. Means this is also one rule, Tarjagahi rule. You will know it about it in the next slide. But here you will see always base area will be more than the thickness of the foundation. Here you can see the this one also B and this one also B. Means both parties equal. That's why it is called square foundation or square footing. Come on the rectangular footing. Here you can see here length is higher than width, and that's why it is called rectangular footing. And there is also ground surface. Sometimes we also denote it by the GL. GL means ground level. And you can also see circular footing here. This is your base, and this is your thickness, and this is your total depth. D means overall depth. We also denote overall depth by the D, as you can see here. And next one you can see, this is your continuous footing. As you can see here, it is a bearing wall, and this is the base, and this is your ground level. And I hope by this picture you will understand and you will get idea what are the difference between square, rectangular footing, and what are the difference between circular and continuous footing. In many exams, these types of question can be asked. What will be the size of B and L of a square footing? There you have to give the right answer. Like B and L both will be in same size, and that's why it is called a square footing. Now there is also one more picture. You can see this is your circular footing, and this is your continuous footing. And this is your combined footing. And combined footing, generally what we did, we make a one slab. As you can see here, this is your slab. And then we make a column on it. As you can see, there is two column and it is combined together with this rectangular uh, member. That's why it is called combined footing. And this is your ring footing. As you can see here, sometimes we need to make it for a big structure. It can also bear the it can also bear the high load. That's why we need to make a ring foundation. Now, as you can see here, this is a picture of combined and strap footing. As you can see in the previous slide, this is your combined image of combined footing. But if you will see the size of rectangular, it is same in the all direction. But in this image, you will see the shape of this rectangular is not equal everywhere. This is one rectangular and this rectangle, this is second rectangle, and this is a strap. We can also call it a beam. It is joined by a beam. Means this is your square footing and this is your square footing, and it is joined by a beam. And this kind of footing will also called combined footing or strap footing. You can also call it strap footing. If anybody will ask you what is the difference between combined footing and strap footing, you can answer it by it. You can see this is the real photograph of a combination spread and strip footing, which you can see here. These are the columns and these are the footing. This is footing for this column, and this is a strap, means this is a beam which is connecting this one. As you can see, there is 1, 2, 3, 4. There is 4 column which is connected by a strap and which is connected by a strip. This is called combined footing, and sometimes we also called it strap footing. Now, come on the mat footing or mat foundation. As I as I told you earlier, if anybody will ask you what is the difference between foundation and footing, there is no any difference. Only sometimes we call it foundation and sometimes we call it footing. And generally we use footing word with the shallow foundation, types of shallow foundation. Okay, come on. This is the image, and this is also a section. This is the front section of front elevation of your mat footing, as you can see here. These are the column, and these column are combined together with a rectangular member. That's why it is called mat foundation. It is showing like a mat. As you can see also here, uh, this is also your types of mat footing, and these are the different kind of mat footing which we construct according to our requirement. Now come on the deep foundation. Now we will see the deep foundation. As you can see, what is the purpose? And purpose is transfer building load deep into the earth. As you can see here, this is drilled, and we also call it poured, and this is driven. This is the image of a deep foundation. Now come on the primary factor affecting foundation choice. What is the factor about the foundation choice? Like if you are a civil engineer and you have to make a choice, what kind of foundation you are going to build, then what factor will be involved in these things? First we will see here surface soil. Second is groundwater condition, and third one is structural requirement. And which these are the factors which affect when you do the choice for the foundation. Now we will see the bearing capacity. What is the bearing capacity? Yes, now we will know about the bearing capacity. What is the bearing capacity? Bearing capacity is also a term like what kind of load soil can bear and how much amount of load a soil can bear. This is called bearing capacity of a soil, and this is applicable for anything. Like if there is also any structure, there is also any building. If anybody will ask to you what is the bearing capacity of this building, means how much load it can be bear. That is the meaning of bearing capacity. And same like soil. Soil, like if you are going to build any kind of structure, then you have to know about the bearing capacity of that soil. Means how much load your soil can bear the load. That is very important to know, because if you will apply the more load on the structure, what will happen? Structure may be collapse because of the bearing capacity. First, it is very important to know what is bearing capacity of your soil, so that it can bear the load of a structure. Suppose this is a structure and it is your ground, so that ground can bear the load of that structure. It is called bearing capacity of soil. Now, as you can see here, I already told you what is the definition of a bearing load, and now we will see the graph. This is a graph. This is a graph which you can see. This is your structure and this is your foundation. And when load will be applied on this ground level, what will be happen? There will be a vertical movement here like this, and there will be also deterioration. What is the meaning of deterioration? Means there will be a bulking of your structure. Means soil can be came in the bulk form. That is not a good for the structure, but this is the acceptable. These kind of shear or bulking things will be acceptable for the any structure, or and it can also restrain, it can easily restrain your foundation. But when you will see unstrained and deterioration of structure, there you will see this is a bulking and this is also a bulking, and shear load is acting like this, and in this structure acting like this, means what will happen? It cannot restrain the load of your structure, and your structure may be fail. And this is your graph of a load and settlement. As you can see here, this is your deterioration, and this is your local cracking, and this is your theoretical failure. And where what will happen when theoretical failure will be happen? Rapid downward movement shear failure. Means these kind of things can be happen during the load. And this graphic showing bearing capacity failure, how any structure can be failed due to the bearing capacity, due to the low bearing capacity. A is showing, as you can see here, there is two graphs. One is A is saying load settlement curve. This is the graph of your load settlement curve. And second graph is deterioration, cracking, shear, and blazing of soil adjustment to the foundation. This is your second graph. Now, this is also very important to do plastic analysis of bearing capacity. This is the your graph which is showing the plastic capacity, and we can also call it plastic analysis of your bearing capacity. And these things you can see here, and this is your load, this is your structure which is acting load, which is transferring load in the ground, and this is your linear shear, and this is your radial shear. Radial shear is the form of curve, as you can see here, and this is your graph. Now, if anybody will ask you a formula, what is the bearing capacity of soil? It will be BB by 2 NV plus C NC plus Q. This is the very important things, and this is the differences, and it is also your dimension, and T is also your dimensionless. Here is this showing, and differences arise due to the various shapes assumed. And this is the very important formula which you need to remember always, because help of this formula you can solve many question which is related to bearing capacity of soil. Now, this is the also, as I told you earlier, Tarjaghi given the too much. Tarjaghi did a lot of work on the bearing capacity of a foundation, and he also given many formulas for the square footing, for the deep footing also. As you can see here, this is equation for ultimate bearing capacity of a street footing. First, you need to know what is the ultimate bearing capacity of a soil. What may be the ultimate? There is like ultimate, and there is also some word in civil engineering. There is some word of uh, you have heard about it, like uh, limit bearing capacity, limited bearing capacity, and this is that thing you can also call permissible bearing capacity of a soil. Permissible means on the point, uh, on the maximum point when you are permitted to put on load on the structure. And ultimate means now you cannot apply a single load on your structure. That is called ultimate bearing capacity of uh, anything, or you can call ultimate bearing capacity of your soil. And this is the formula, as you can see here: Q equals to C dash NC plus gamma D, df plus nq plus 0.5 gamma bn and y, where NC, NQ, and N are the Tarjaghi bearing capacity factor and depend on the angle of shearing resistance phi, shape of the failure of surface. And this is also ultimate bearing capacity for square and circular footing, which is based on the experimental result. Tarjaghi suggested following equation for the ultimate bearing capacity for square footing. This formula will be applied: Q is equals to 1.2 C dash NC plus gamma DF NQ plus 0.4 gamma BNR. For circular footing, QU is equals to 1.2 CNC plus gamma DF NQ plus 0.3 gamma BNR. This is a very important formula. Suppose you are giving GET exam and you are sitting in government exam, this formula will definitely come in your exam. If this formula will not come in your exam, any numerical will be related to any numerical may become in your exam which will be related to this formula. That's why it is very important to remember this formula. And this is also bearing capacity factor. This is graph showing bearing capacity factor, and this is NC, and this is NQ, and this is N gamma, as you can see here. And these are the bearing capacity factor. And now this is the given the IS code, and this is very important to know. And you cannot remember these things, but you can easily get these things from the IS code. Now, Now we will see the modes of shear failure. What may be the modes of the shear failure? Means how soil uh, can be failed due to the ultimate load of a structure. There is given classified shear failure of soil under a foundation based into three categories depending on the types of soil and location of foundation. This is first one is called general shear failure, second one is called local shear failure, and third one is called punching shear failure. Now we will see what is the difference between local shear failure and punching shear failure. Once we will once we will understand again about the bearing capacity. As you can see here, bearing capacity is the load which soil can bear the load. That is called your bearing capacity. As you can see in this image. Now, what is the geotechnical engineering do? They check the bearing capacity of soil and they apply it on the soil. And this is also your design system to safely, and you can also say design system to safely transfer the load from the structure to underlying soil. This is also called your bearing capacity. Now, as you can see in this animation video, this is your soil and this is your structure. And what is happening if shear, if large enough the shear force is induced, the soil will become the higher. And now then what will happen? And then your structure can be failed. Now we will see the what is the bearing capacity failure modes. What are the, you can also call it, what are the types of your bearing capacity failure. Let's see here by the help of this animation video. uh, it will first you can see here, first one was punching, and second one was here, you can see here, second one was local failure, and third one was uh, general failure. Now we will see what is the difference between punching failure and local failure and all this. This is the image which you can see here, and this is showing the displacement due to the this structure. And if you will see the in real, what will happen, as you can see here by the help of this image, and this is called your punching shear failure. What is happening? Soil is failing in this form. Now we will see the local failure, local shear bearing failure. What will be happen? How displacement will be done? One part will be done from here, second part will be done from here. As you can see the image, this is your local shear failure. And now we will see the general shear failure by the help of this animation video. It will rotate in this direction, in one direction, as you can see here. This is showing the shear failure. Now, what is historic failure? Now we will see the historic failure which happened uh, in this world. It will, it is also a structure, and this is also called grain elevator, Transcona grain elevator in 1983. As you can see, what happened due to the shear failure in the real structure. You can see the image. All structure are collapsed due to the low bearing capacity of soil. This is very important to know what is the bearing capacity of soil where you are going to build your structure and what is the solution. As you can see in this animation video here, you can also make a mat foundation here. They are also giving the mat foundation, and mat foundation, what will happen if area will be increased, your intensity of load will be decreased. Like if area, as we all know, uh, uh, pressure is equals to load upon area, and pressure is inversely proportional to area. If area will be increased, pressure will be decreased. And this phenomena work in the mat foundation, as you can see in this video. This is your this is also your solution. There is also solution of mat footing. Second one is solution of pile group, and pile footing, you can pile foundation, you can call it. And now we will see the components. What was the components? Aggregate peers, as you can see here, this is grouting, this is soil mixing, and this is compaction. You can apply these method during your pile foundation, as you can see in this video. So this is very important. Like whenever you are doing work or you are making any kind of structure, it is very important to know what uh, will be effect on the soil. Means your soil can bear the load of your structure or it cannot bear the load of structure. For this, you have to go for soil testing. For that, we need to do a lot of testing in the geotechnical engineering lab. We need to find the bearing capacity of soil. We also need to find Proctor test density of the soil by the Proctor test, by the sand replacement test. There are too many methods by which we can easily find the load bearing capacity of soil. Now we will see the first question, first and second questions. As you can see, the void ratio of soil sample decrease from 1.50 to 1.25 when the pressure is increased in the form of 25 tons per meter square to the 50 tons per meter square. The coefficient of compressibility is means it is asking what will be the coefficient of compressibility. And as you know, compressibility is also a part of bearing capacity of soil. That's why you can answer it from here. And your correct answer will be option A. As you can see, option A is 0.01. Okay. And this is very important question. These types of question may be asked in SSC exams, in your GATE exams, and you are sitting for the state government exam there. These types of question may be also came. That's why it is very important to know what will be the coefficient of compressibility. Now we will see the second question. What will be the answer of second question and what is asking in the second question? First one was related to compressibility, and let's see what is the second question. The coefficient of active earth pressure for loose sand having an angle of internal friction of 30 degree is. What will be the value? In this question, it is asking what will be the coefficient of active earth pressure for the loose sand. Okay, and this is given in book, and you can easily remember these things, and it will be option A. Means your right answer will be option A, 1/3. And this is also very important question, and it is related to coefficient of earth pressure. Now we will see the third question. What is your third question? Third question is the maximum net pressure intensity causing shear failure of soil is known as. Means here it is asking the maximum net intensity, or you can also call it maximum net pressure intensity. Here is four options as you can see here. First one is safe bearing capacity, net safe bearing capacity. Third one is net ultimate bearing capacity. Uh, uh, as I told you earlier, ultimate bearing capacity. What will be the right answer? Here, right answer will be net ultimate bearing capacity. This is also very important question, and it is related to your bearing capacity, as you can see here. Now we will see the fourth question. Fourth question, it is if the degree of saturation of partially saturated soil is 60%, then air content of soil is. It is asking about the air content. Then what will be the air content of your soil? And by the formula, you can easily solve this question. And this is also very important question. And when we will see the correct answer will be 40%. A will be your correct answer. This is your correct answer. Come on, the next question. Next question is about which one of the following statement is true. There are four statements. First statement is clay are more porous than sand. Clays are more porous than sand. This is wrong sentence, as we all know. Pressure of organic matter in the soil decrease the bearing capacity of soil. This is the right answer, right sentence. And aluminous cement is used for the foundation in the soil uh, with the chemical deposits and all of the above. Let's see what will be answer. Yeah, answer will be D. Means all sentence which is given here, all are the correct, and that's why your right answer will be D, and option will be all of the above. Now we will see the sixth question. According to a yes classification, the range of silt size particle is. It is asking what will be the size of a silt particle. Silt. This is also silt. This is also a type of soil. And what will be the range of these silt size? Let's see what will be the answer. Answer will be D. Means 0.075 mm to 0.002 mm. This will be your right answer, and this is very important question. In many exams, this question will may be asked to you, and they can also ask what will be the size of uh, clay and what will be the size of sand. So it is very important to remember what is the size of silt, what is the size of clay, and what is the size of sand. As we all know, if you will see smallest one is this clay, then silt, and third one will be your sand. Is about pick up the clay soil group which does not swell when wet from the following. Let's read this question again. Pick up the clay soil group which does not swell when wet from the following. First one is kaolinite, second one is mite group, and third one is vermiculate group, and last one is montmorillonite group. And let's see what will be your right answer. This is also very important question. Right answer is the mite group. This will be your right answer, and it will not swell. Means it will not change the shape when it will be wet, and this is called mite group of soil. And this is very important to know for all civil engineering students. Come on the next question. Next question is about coefficient of consolidation of soil is affected by. Here is asking how the coefficient of consolidation of soil will be affected. First option is compressibility, second option is permeability, and third option is both permeability, compressibility and permeability, and last option is none of the above. Let's see what will be the answer. Answer will be both compressibility and permeability. Means if um, if compressibility and permeability will be changed, your coefficient of consolidation will be also affected due to the uh, changes in the compressibility and permeability of the soil. Now let's see the next question. Next question is about pick up the correct statement from the following. First question, first statement is when water table is above than the base of the footing, the dry weight of M should be used for the soil below the water table. What is the second? When water table content is located somewhat below the base of a footing, the elastic wedge is partially moist soil and partially submerged soil, and suitable reduction factor is used. Let's see the third sentence, third statement. When water table is just at the base of the footing, no reduction factor is used. And D option is none of these. And it will be your right sentence only will be B will be your right sentence. When water table is located somewhat below the base of footing, the elastic wedge is partially of moist soil and partially of submerged soil, and suitable reduction factor is used. This will be your correct sentence. B will be your correct sentence. Let's see the 10th question. What will be the answer of it? Select the incorrect statement. Effective angle of shearing resistance. Here, increase as the size of particles increase. Increase as the soil graduation graduation improves. C is it is limited to maximum volume of 45 degree, and is rarely more than 30 degree for the fine grained soil, and it will be C will be your right answer. E is limited to maximum value of 45 degree. These two are very important questions. That's why we need to cover it also. What is the relation between void ratio and porosity? And in earlier lecture, I have explained what is the relation between void ratio and porosity. As you can see here, right answer will be here D. It is equal to it is E is equals to n by bracket 1 minus n. What is the meaning of n? N means porosity and E means void ratio. This is the relation between void ratio and porosity. Now there is also one question, important, very important question. Relative density of compacted dense sand is approximately equal to. Here you can see here 0.04, 0.06, 0.095 and 1.20, and your right answer will be 0.95. These questions are very important. Uh, if you are going to do preparation of your government exam after your graduation, these questions can help you a lot, and it is very necessary to remember these questions during your graduation. Okay. Now, in this lecture, we have done the study of shallow foundation and deep foundation. And now we are very well aware what is the difference between shallow foundation and deep foundation. And there is one more thing very important, and you should have idea what kind of footing is proper for the structure. Like if you are making a high-rise building, then what kind of footing you are going to make and what kind of footing you are going to construct. Like if you are going to work on a high-rise building where you need put a load, more load on the structure, in that condition you can easily make the mat foundation. If your structure is very lightweight, in this case, you can easily spread footing. This is also very important to know where you will prepare your spread footing. And this is also about the deep foundation. There is also driven pile, drilled shaft, and other cast piles. And where you need to build the deep foundation, this is depend on it will depend on the load of the structure, and it will also depend on the bearing capacity of soil. As we also uh, I also told you about the shallow foundation, deep foundation, and one more thing which is very important: bearing capacity of soil. In bearing capacity, we discussed about ultimate bearing capacity, permissible bearing capacity, and there was also the types of bearing failure, how structure fail due to the higher load. It is also very important to know. Now, this is the end of lecture, and here from where I am teaching this thing, and this is your geotechnical book, which is also called Soil Mechanics, and it is written by T.N. Ramamurthy. And this is also he is also there is also co-author. And one more thing is very important: NPTEL link. This is NPTEL link, which is very easily you can type on your computer, and you can watch a full video by the IIT's professor. And in this lecture, everything has been explained very deeply. But before watching NPTEL videos, you need to know what is the basics of the geotechnical engineering, and what is the basics of what is the basics of foundation, what is the basics of bearing capacity. So this is very important to know. First, you should know about the basics. What is the basic? If you don't know basic, you cannot go for the advanced. First, you had to learn basics. You can start it from the first video. If you will watch first video is about the three-phase diagram. This is your second videos. Second videos you can also search on YouTube, and this is your third video, which is about the foundation and which is also about the bearing capacity of soil. And before watching this video, uh, you don't need to read anything. Only you can watch this video and you can get an idea of foundation. Okay, this is very important things. And now I'm going to close my video. And this was all about the foundation and bearing capacity of soil. Thank you. Thank you so much for watching.